Just in time. So we're going to start out and we're going to fill in the blanks. And we're going to talk about special log bases. So remember that the base of a log is the little number that's down by the tail of the G. It's a subscript. And so we're going to talk about special log bases because last class, everything that we did, it had some number. It was a 3, a 4, a 7, some number. Sometimes there's not a number at all there. So if you look at your notes, question 5. So look at your notes, question 5. Do you see how there's no number there? No base number. So this is similar to that when you write a square root, you don't put an index, but we know that it's a 2. Well, if there's no base number, we know that it's a 10. So there's a special base of 10. And we call that a common log. And it looks like, see, there's no base. So when you don't see a base, the base is 10. And just like last unit, if you needed to draw the index of a 2 on your square roots to help you, if you need to put the base as a number 10, you can. It's not wrong. But when it's not there, it is a 10. So again, when you look at question number 5, that is a base of 10. And if you flip it over to the back, if you look at question 11, it's also just a log with a base of 10. There's another log down there. See if you can find another log that looks a little different than the stuff we did last class. A log with a base of 2 is no different than a 3 or a 5 or a 4. Do what? Oh, you were saying number 2, not base of 2. Is that what you were saying? You are correct. Sorry, I misunderstood what you were saying. You're saying question number 2, it looks different. That is correct. It looks different. What 2 letters do you think those are? Okay, that is what everybody thinks. That is not the letters. Okay, when you are writing this, these letters stand for natural logarithm. Natural logarithm. It is a natural log because a lot of times these are used to solve problems that may include nature or like population growth, things like that. So it's things that happen like naturally. So it's a natural logarithm. And the letters are LN because it's like French, I believe. It's like logarithm natural. So it's LN. It is not an I. That is an L for natural logarithm. LN. And then it has a base of E. What is E? Well, if you look on your calculator, right underneath that log button, you'll see in blue, E to the X. E is a number. E is a number like pi. So if you look down the right side of your calculator, you've got the clear button and then the divide button. The divide button, above the divide button, I believe that's where the E is. Yes. So type in the E. You have to do second and then the divide button. That's the E. And then press enter. Do what? Yeah, it's a long number. So you remember learning about pi, and pi is 3.14159, blah, 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 and it keeps on going. The E, it's down the right side. It's with the divide. So press second and then the divide button and then press enter. It's a number, just like pi is a number, 3.14159. Euler's, this is called Euler's number. It's 2.718, blah, 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 blah. It's called Euler's number. And it sounds weird, but Euler is with an E. That is called Euler's number. I know it sounds weird. That's not how you would think to say Euler. So again, a natural log, and it doesn't show a base, but it is base E. And E, it's an E because it's Euler's number. It's an ln because it's logarithm natural. So these are just special logs. But for what we're doing today, they work exactly the same way as a log with a number base. So when you see these, doesn't change the way we're going to use them. They're just different. So at the top, it says, let B be the base of a logarithmic function. B is going to be bigger than 0, but not equal to 1. Let M and N be positive numbers or variables. Okay. Well, what we're going to do is take and expand or condense these. And that's all you're doing is either expanding or condensing. You're not solving anything. So just like we had exponent rules, we have log rules, and they're actually very, very, very similar. So this says that when you're adding logs and they have the same base, so whatever the base is, it's the same. When like bases are added, they combine to multiply. So this is just like when you multiply bases, you add the exponents. It's very similar. So what that means is that they can be put together and they will form one single log with whatever that base is. And remember, a base needs to be little. And then you're going to take the two things and they're going to multiply. So if you have two logs and they have the same base, you can put them together. And if they're adding, you're going to multiply the stuff. So what do you think that we're going to do if we're subtracting? Divide. If you have two like bases, we can put them together and we can divide the stuff. So whatever is written first has to be on top. For the next one, this says that when a log is multiplied, it can be written as, so whenever you are multiplied by some value, it can come over here and it becomes your exponent. It can be written as an exponent. So we can rewrite that. And it becomes an exponent. And I put parentheses, but whether you put parentheses or don't put parentheses, it doesn't matter. A lot of times this stuff that you're taking the log of is put in parentheses, but if you put them or don't put them, it doesn't make it right or wrong. So because we're working with exponents and subscripts, you have to be very clear about what you're writing. So if it's a subscript, it needs to look like a subscript. It needs to be down by the tail of your G. If it's an exponent, it needs to look like an exponent. It needs to be up to the top. So these don't make a whole lot of sense until we actually start using them. So the first question. This has two things and they're being multiplied. So if you're multiplied, you can expand it. And if you were multiplied, when you expand it, they're going to what? What are you going to do with those two logs? This is the very first property. Add them. Very good. So when we expand that, I can split it apart. So when it's expanding, you do just that. You kind of make it bigger. So if you were multiplying this stuff, you can expand it and it's adding. For the second one, you're dividing. So what's going to happen when we expand it? We subtract it. So remember, this is an LN. Any questions so far? The next question, we're going to do the same thing. I have a bunch of things that are being multiplied. So my first step is to spread it apart. And when I multiply, what are they going to do? Add. So I'm going to first split them all up. So don't forget your base. Everything has to have the same base. So any questions so far? All we did was expand it out. This one has another layer to it. So do you see how I have exponents? I meant to put in our chart that. So add that to your chart, that when you have an exponent, it comes out in front. And then when we get to the back and we are going to condense things, you have an exponent, you can, sorry, if you're multiplying, you can make it an exponent. So do you see how I have an exponent? Anywhere where I have an exponent, I have to rewrite it another time because these have to come out into the front. So anytime that you have an exponent, it's in this chart. So anytime that you have an exponent, if you want to expand it, you got to write it out into the front. So it looks like this. So I have to put these exponents out into the front. And now I am expanded. For the next one, I am dividing. So when I divide, how does it split? subtract. So I'm going to do this bit by bit. So I'm first going to subtract. Is there anything else that needs to be split up or expanded? Yeah, so that 4n squared, that can be split up. So they're multiplying. So when I split them up, they're going to add. So I'm going to split up this part right here. Very good. And then I noticed that I still have an exponent. So that one's going to have to be rewritten into the front. And then I'm fully expanded. We are not solving anything. All we're doing is expanding. So here, it's not expanded, it's all condensed, it's all together. So first thing I can do is split it up. It was dividing. So when you divide, you subtract. And then I look to see if I can expand it anymore. Well, that can be expanded further because they're multiplying. So I can split them up. This one can be expanded even further because it has an exponent. So it can be written out in front. So all we're trying to do is make it to where it's just a log of just one thing. I'm going to give you guys 3 minutes. I want you to go do however many you can do on your homework. Huh? Right. I just want to see if you can do the first 3 or 4 on the front. I'm only giving you 3 minutes. You can't do very many. Well. Good job. Do what? You can distribute it into both of them, the top and the bottom. Uh-huh. So it'll be in front of both of the logs. Mhm. All right, the next two questions, why do they look difficult? Yeah, it has a square root. But I believe we can do it. Our first step still, we are multiplying something, so same first step, you're going to split it up and it's gonna add. This first step, same first step. So for question number 6, you have the same also first step that we'll have log base 4, and then we'll have the square root of x minus y. So we need to remember from last unit that you can rewrite any square root as a rational exponent. So a square root means that you're raised to what power? Does anybody remember? So close. 1/2 power. So the square root of something means the same thing as to the 1/2 power. And if we have an exponent, where do we write it to expand it? Into the front. Oh, why'd I do that? Do what? Mhm. So anytime you see a square root, it's the same thing as to the 1/2 power. So the second, or question number 6, we can change that square root to the 1/2 power. And again, if you have an exponent, you can rewrite it into the front. Good job. Yep. She's struggling over there. She needs some support from her friends. It might be easier on the backside when we're condensing. And maybe once you condense, you'll feel better about it. So anytime you see a square root, it's the same thing as to the 1/2 power. Which also means that if we take a look at the backside, Do you see how question number 9 has a 1/2 power, or sorry, a 1/2 out in front? That means that the m is going to end up in your final answer as a square root. Before we get there, this is a student supplied brain break. Would you rather, from now on, because I don't have time, would you rather be overdressed or underdressed? I don't think underdressed as in less clothes. I think underdressed as maybe you're wearing, like, you look really comfortable today, but if she was going to a formal dinner, probably that would be underdressed. Oh, that's underdressed. Overdressed would be maybe you came in like a prom dress to school. That's overdressed. I'd rather be comfortable. Just depends. Would you rather have telekinesis or telepathy? First, let's talk about the difference. Who can tell us what telekinesis is? Moving things with your mind. Yes. What about telepathy? Like communicating with your mind and somebody else's mind.
Can you control it really good, or can you only pick up like a pebble?
I don't know. Maybe you got to exercise your strength. I don't think I would want telepathy. Like I already hear like as a super strength. And so I already hear the things people say. I don't want to get into anybody's mind. Okay, maybe if you want to be able to communicate with your best friend or something, and you don't have to speak. But if you could like talk to them, like if they could hear you in their mind. I don't know. A lot of people want to fly. I don't want to fly. I mean, just some people have.
Make yourself fly.
I know, but that's not something I would want to do. Maybe. So would you rather never be able to go out at day or night?
Night, because you're always out.
I would want to, if I had to be stuck in my house either during the day or during the night, like I need the sun. Like the sun makes people happy. I need to be able to go out during the day. If I had to be cooped up, I'd rather be stuck at the house during the night. Madeline says party hardy. YOLO. Maybe you just have to have all the parties at your house.
Every time you buy your time, every time is it like a page in like some kind of thing you're reading?
I guess it could be like when you're turning the page. But it's a page of paper. I bite my lip sometimes and I hate it. I bite my lip. I don't bite my tongue very often, but I bite my lip. I don't like it. I tend to agree. Like you need to eat to stay alive. You'll get a Kindle. Yeah. I suppose. Especially for like shy people, y'all would want to do probably neither. But I would probably rather sing along than dance along to everything.
Yeah, so if you can't sing, that's the song. Go on, dance. Yeah, I'd rather be dancing. Dance. Like, I could dance to this song right here. Yeah.
Yeah, I guess you can dance to a song that you don't know the words to, but it's hard to sing to a song that you don't know the words to. That's true. That's true. That's true. All right, on to the back. We're just going the other direction. It's the same stuff. We're just going the other direction. So for question 7, we are adding. So if we're adding, how do we go the other direction? So Nadeline, this one is adding. So if we put them together, very good. Why are you saying you're struggling? You're doing good. And that's it. Yes. Book. Bless you. You didn't necessarily. I just didn't want y'all to have your phone. For the next one, see if you can do the next one on your own. I switched the 3 and the X because we don't usually write 3 times X as X3. All I did was, you don't get it? Well, I just wrote the X, I mean, 3 times X is the same thing as X times 3, right? You can multiply in any order you want to. I switched them just because we don't usually write the number second. Like, we're just multiplying. As number 1, it's the same thing as number 7. Number 7 and number 8 are basically the same thing. But we don't usually write the variable first. We usually write the coefficient first. Are we good so far? The next question. So anytime I see a 1/2 out in front, it tells me that something's gonna be what? Square rooted. So anytime you have something written out front, it has to come to be an exponent first. But anytime that you have a 1/2, it is gonna be a square root. Now I can put them together. If I'm adding, how are they going to put together? By multiplying. Yep. That's it. There we go. It's highly likely that, let's say this was a question on an assessment. It's highly likely that that might be rewritten to be in the front. It's the same thing. So just be careful sometimes. It doesn't really matter. However, like this could look like, if you were sloppy, it could look like it's going over the N. So sometimes this might be written in the front as a coefficient. For the next problem, there is a 3 outside. It needs to distribute into both pieces. And now I have something in the front, so I know that these are going to be exponents. Sometimes the natural logs start looking like a 1 and then an N, and so N? Oh, like IN. But I have to condense it. I have to put it together. If you're condensing, you will end up with one logarithm every time. So I'm going to put it together. And because I'm subtracting, I will what? Divide.
Plus our.
You just have to do them in order that you see them. But we're almost done. There's one last thing. So your quiz has a multiple choice. And there's one last step to this. It's just putting the 3 on the outside of the parentheses. So when you condense something, you want to try and have the least amount of things written. And so instead of having the exponent of 3 in the numerator and denominator, it's more condensed to just put it on the outside. So the way that you would see it on your quiz would be like this. So if a square root means goes with 1/2, what kind of root do you think goes with 1/3? A cube root. Well, it's the root and then you put the little index of a 3. For question 11 and question 12, I'd like for you guys to try them. See how far you can get. I'm going to put them up on the board, but you have to try them first.